Hello guys, welcome to another episode of GeeklyEDU. My name is Eddie, and today we'll be talking to you about power series. So, before I get into it, you guys remember what a geometric series was, right? So, a geometric series looked kind of like this. You have a x power of n, where a is a constant. And then it is convergent if the absolute value of x is less than 1. So, an important thing that we need to keep in mind when we talk about geometric series and then when we expand this definition to power series is that we will be talking, the concept of convergence will change. Because now we may have convergence only for certain values of x. So, we're not going to be talking about a series being just convergent or being just divergent, but we're going to say that it is convergent within a given range or divergent within a given range. Now, a power series is going to be an extension of a geometric series. And basically, it's going to look like this. So, I don't know if you can see, but the big difference is that the number that's multiplying x to the power of n now varies with n. So, when we expand the series, we're going to get z0 plus c1x plus c2x squared plus c3x cubed plus c4x to the power 4, and so on and so forth. And then these coefficients, as they're called, okay, these are called coefficients, can be any function that depends on n. So, what do we do now? Well, we're going to realize that what we have here, this, is just a polynomial. Which means that if convergent, a power series will be a polynomial, which we can call f of x. Alright? So, if we go back to the example of the geometric series where we had n equals 0 to infinity of a x to the power of n, when we say that the series converges, it converges to this. But what is this? Well, this right here is a function, of x. So before, instead of x, I had used the letter n, but it's just a variable. It doesn't matter. And then, in this case, I say, well, f of x exists, that is, converges, if and only if the absolute value of x is less than 1. So then, again, repeated. A power series is just a polynomial, okay? A very long polynomial that has a lot of terms. But it is just a function. And then we know that when we plot functions, they may go to infinity and diverge, or they may just converge to a number. And that's what we're trying to find out. We're trying to find out if our specific polynomial goes to infinity or not. Now, there are many ways to do that, but we'll leave that for another video. What we're going to do now is look at some common examples. Now, of course, when you look at something like this, you think like, well, that's a very specific function, because not every function could be equal to this infinite sum of terms, right? But that's actually not true. For example, we have e to the power of x, a very, very well-known function, which can actually be rewritten as this infinite series. X to the power of n divided by n factorial. So remember that for a power series, we're going to have x to the power of n, and then this Cn can be anything. There can be factorials, there can be a polynomial there, a sine, a cosine, just anything. Okay, just a function of n. So then e to the power of x is basically equals to x1, 1 factorial plus x squared divided by 2 factorial plus x to the power of 3 divided by 3 factorial plus x to the power of 4 divided by 4 factorial, and so on and so forth. And we're going to say that this is going to be true for any x. So then e to the power of x is a very special function, because no matter what the value of x is, we can say that this is equal to this. Now, more examples. Well, we're going to have sine of x, which is actually equal to this massive thing right here. And I'm going to have x to the 2n plus 1 divided by 2n plus 1 factorial, and then cosine x is equal to -1 n x to n. And then again, this is going to be true for x, for any x that is basically a real number. Now, again, guys, we can do the same thing for a variety of different functions. And this is something that's used in applications a lot of times. A lot of times, maybe using the exponential function is not the easiest way to go around. So then you say, well, this exponential function right here is actually equal to this large sum here. But maybe I don't need all the terms in a sum. Maybe if I take the first 4 terms, I'm going to get a very good approximation of e to the power of x. So we can start to see some of the possibilities of these tools. And then another fun fact, then after this, we're going to wrap it up. You guys know that the derivative with respect to x of sine of x is equal to cosine x. Now, well, something you guys can do as homework is check that if we take the derivative of this whole thing right here, we will get exactly this. So, alright guys, as a summary, power series are basically an extension of a geometric series. We have a series that looks like this, where we have a variable coefficient c of n multiplying x to the power of n. And basically, once I expand that summation, I sort of realize that I'm getting polynomials. The coefficients for each term in the polynomial may vary, but it's a polynomial nonetheless. So then it is critical for me to find the range within which that polynomial will converge, within which I can actually say that a power series is equal to f of x. And then once I do that, I can actually use this to my advantage in a wide variety of problems, and we'll do more videos about it in the future, and you'll be able to see. But the important thing is to know that we're basically equaling functions to infinite series. Alright guys, so I hope that was all clear. Please leave a message if there was anything that you did not understand. A lot of people may be having the same doubts. We'll try to get back to you as soon as we can. And you know, drop a like, subscribe to the channel. We'll be uploading videos almost every day about a wide variety of topics that could be useful for you. I'll see you next time.